Hello. The topic for today is Agile governance on AWS GovCloud US regions. My name is Kaushik Mohanty, and I'm a business development and specialist sales leader at AWS. I focus on the worldwide public sector customers, and my area of specialization is cloud management and governance. Joining me from Lockheed Martin Corporation today is Diane Kozoboulis, who is an architect and product owner in their cloud services organization. She has been with Lockheed Martin for over 15 years, and she now supports deployment of AWS solutions that enable cloud governance. Over the next 30 minutes, we will talk about how AWS helps customers with its cloud management and governance services. We will double click on one of those services, AWS Service Catalog, and then Diane will talk about Lockheed Martin's Agile transformation with Service Catalog in both AWS GovCloud US regions. She will also share the lessons they learned, something you may want to consider as you embark on your cloud journey. There's over 15 AWS services that fall in the category of management and governance. Native integration between these services enables automation. These fall in three categories: enable, provision, and operate. Enablement services like Control Tower and organizations set up multi-account AWS environments and enable governance at scale. Likewise, budgets and license manager. Provisioning services include Service Catalog, Cloud Formation, and Marketplace, and I'll be talking about them at length later in the presentation. Operate category deals in ongoing monitoring and management of your AWS cloud environment. And this goes beyond day 1 to day 90, day 360, keeping your environment governed, secure, and compliant. CloudWatch, CloudTrail, Config all fall in this category. So what do organizations want? They want to govern effectively on the cloud, keep their environment secure, compliant, and manage the operations effectively with automation, and also control spend. At the same time, they want adoption of the cloud, for which they need to be agile. And by that, they want to offer some self-service capabilities, some autonomy to their end users, who could be lines of businesses, could be DevOps users, or data scientists. They want to be able to experiment fast. They want to respond to changes quickly. And this is where it tends to be a little counterintuitive. And what Service Catalog tends to do for our customers is establish a handshake between these two paradigms. So you don't have to choose between agility and governance. You can get both. And the way Service Catalog does that is by organizing your resources in the cloud, governing those resources, sharing those resources across users and accounts, and while doing all of these, enable self-service for the end users. What happens if you do not have this kind of a governance mechanism in place? If, for example, an employee requests for a server, there are broad choices on the AWS console, and it is very likely that the employee may not necessarily know what VPC to set up, what kind of VMs they need to use to be compliant. And those are areas where you want to make sure that you're doing it right as an organization, and you are able to monitor usage, product versions, and costs. Trying to do these without automation is time consuming and resource intensive, and building automation adds to software development burden. If you grant access, on the other hand, to all of the AWS services, the employees would log in and see a myriad of services, all of which could be configured in different manners. And that could again cause some angst for management and for the central IT functions, because you would never know whether the VMs have been selected in the appropriate manner and they are configured right, and you want to make sure that they don't leave any ports open for a security or data breach. In addition, it is so difficult and time consuming for companies to trace it down to who actually was involved with that kind of a breach, unknowingly or knowingly. Enter Service Catalog. Let's look at how Service Catalog works, and Diane will later talk about how Lockheed Martin has put it to use. As mentioned earlier, it organizes, governs, enables sharing of resources in the cloud while offering end-user self-service. Anything that can be put in a CloudFormation template can be provisioned using Service Catalog. Example, any marketplace software that is available as CloudFormation JSON files, or any AWS service that supports CloudFormation. If a service doesn't support CloudFormation, they can still be deployed using CloudFormation custom resources. 3-tier or multi-tier applications that are wrappable with CloudFormation can also be deployed, and some infrastructure as code, which is not necessarily CloudFormation, those templates can also be deployed using Service Catalog. The Service Catalog administrator, John, as you see on the slide, essentially ensures that these CloudFormation templates have some metadata associated with it so that you can basically go back to the end users and make sure that they know exactly as to what they are using. After the metadata is added, which is all the vendor name, when it was issued, what version they are using, the Service Catalog administrator also adds some governance constructs in the form of what we call constraints. Constraints could be launch constraints, template constraints, stack set constraints, or notification constraints. Launch constraints, for example, elevate certain privileges for users to launch certain services, while other users can only provision services that have been built for them. In a way, launch constraints help with what we call least privileges. Template constraints essentially defines to what extent they can use the AWS services. So the DevOps team has access to a portfolio that uses template constraints, whereby they can access only a T2 micro EC2 instance, for example. The stack sets constraint enables sharing across multiple accounts up to 1,000 accounts. And these accounts have trust relationships between them. So it can be shared in a hub and spoke manner or via organizations, AWS organizations. And the notification constraint especially notifies when there is a stack event. Now, what the administrator has done is using some of these governance constructs and the metadata that we spoke about, clusters these CloudFormation templates into portfolios. The portfolios or products can also then be embellished with tags from tag options library, as well as you could add a version to it and add some service actions for the end users to use using systems manager documents. Now the products are ready for provisioning by the end user. And that provisioning can happen either through the console or through API, CLI, or using a CloudFormation resource. Under the hood, the provision product is nothing but a CloudFormation stack. So what happens with this? The result is the end users have quick and easy access to a custom curated list of products that can be deployed consistently, always compliant and secure, correctly tagged, and within budgets. So the customers do ask us as to how other customers are using Service Catalog. There are 3 main ways in which they use. Everything is accessible in the portfolio to the enterprise. That fosters adoption, and everything that is in their main portfolio is well architected and pre-approved by the organization. Or you could carve out portfolios, as I was talking about, for the DevOps user, maybe requiring Elastic Beanstalk, maybe requiring Fargate clusters. And the data science guys would be requiring probably SageMaker and some EMR, and you create those portfolios. The third category is fosters what innovation in an iterative manner, because you make those portfolios available and you give some additional privileges to the team leads to embellish those portfolios based on the requirements pattern that they have. So without any further ado, let me introduce Diane, and she will be able to talk about how Lockheed Martin has gone about the cloud journey. Thank you.
Thank you, Kaushik. As stated, my name is Diane Kozabolis, and I'm a product architect and owner for the Cloud Services Organization at Lockheed Martin. We are a global security and aerospace company that employs about 110,000 people worldwide. Our primary focus is on advanced technology systems, products, and services. So let me start by telling you a little bit about our life before the cloud. We had several data centers managed by a central IT team, and with that came some of the pain and complexity that you're probably all very familiar with. We have physical servers and virtual servers, and those require sometimes lengthy provisioning and decommissioning processes. We also have complex maintenance and disaster recovery procedures that requires rigorous coordination across both the infrastructure teams as well as the application teams. And in order to support automation, again, that requires complex coordination across various organizational silos, whether it's infrastructure, application, operations, and so on. With the rise of cloud service providers, there was a growing need from our customers for cloud adoption. Cloud offered the ability for agility within our environment as well as potential cost savings. We also wanted to help break down the silos and improve organizational processes with the use of cloud. We also had several applications that were already moving to the cloud, supported by Shadow IT. In order to support governance of that, the only way we could do that was by consolidating and managing cloud centrally. When looking at cloud providers, AWS was the provider that provided a compliance posture as well as a service portfolio that we needed. Within Lockheed Martin, committing to cloud adoption resulted in our overall mission, migrating over 50 programs as well as over 100 applications to the cloud. To support cloud adoption, there were several initiatives that needed to be completed at both a workforce as well as an organizational level. We needed to implement a strategy that supported business agility, allowed us to be more flexible to and predictably delivered to our business needs. Agile transformation was required to promote Agile adoption across our enterprise, as well as transform the workforce to DevOps principles. We needed to, again, break down those traditional silos of network engineers, infrastructure engineers, application developers, and security engineers, and transition them to full stack engineers. These engineers needed to grow skills in multiple areas, whether it was infrastructure, security, development. They needed to move away from being specialties in one to specialties in multiple areas. We also needed to train our workforce with the necessary skills to support both AWS and DevOps and provide them the necessary tools to successfully perform DevOps in the cloud. We also needed to restructure our organization. This consisted of creating a new cloud organization to enable and drive cloud adoption, providing cloud environments and solutions for all of Lockheed Martin. Within the cloud organization, we created several product teams. They were focused on creating foundational constructs, integration, and guardrails necessary for cloud accounts. These teams consisted of various network, infrastructure, application, and security engineers, either transitioning to or transitioned to full-stack engineers. We also created customer engagement and engineering teams. They were focused on providing the training, expertise, and guidance to support cloud adoption. We developed partnerships with key organizations critical to the success, such as finance for managing cloud spend and the application organization, where they are supporting the migrations, implementing cloud-native apps, and providing tooling and collaboration. And none of this was easy. We had gone through various iterations of agile transformation as well as restructuring our organization to get to where we are today. As we look to migrate applications to the cloud, and with a large percentage of our work in support of the U.S. Department of Defense and U.S. federal government agencies, AWS GovCloud played a critical role in our adoption. GovCloud has four main fundamental characteristics to support our compliance needs. You have logical and physical separation, allowing for infrastructure to be managed differently to meet DoD and government security requirements. You have management by U.S. citizens, and it adheres to both ITAR and FedRAMP compliance. Lastly, you have required security auditing for any service that's brought online in GovCloud to ensure compliance. This resulted in our cloud adoption initiating in 2015 with GovCloud-only deployments. As we started to better classify where the data could reside, we transitioned to also supporting commercial deployments in 2018. Today, we are still primarily GovCloud focused, and 90% of our workloads reside in GovCloud. To identify whether an application should reside in GovCloud or commercial, we developed internal guidance based on the type of data handled by the application. This chart focuses in on the data classifications resulting in required GovCloud use as of end of 2019. At a very high level, to summarize, first we look at the data sovereignty of an application. If it's U.S. sovereign data, essentially government contract data or expert controlled, the data should reside in GovCloud. Now, drilling down into the chart, we call out specific regulations. If the data classification is DFARS, ITAR, for official use only, or DOC, the data must reside in GovCloud. For Department of Energy, Nuclear Regulatory Commission, and other agencies with ECI data, again, it must reside in GovCloud. Other types of U.S. regulated data that do not contain expert-controlled information could potentially reside in GovCloud or commercial. Examples of this could include personal information, such as protected health information and payment card industry. We incorporate this GovCloud guidance into our account request form. So whenever a user requests a new AWS account, part of that process is they have to identify the data classification, and the workflow behind the form will automatically drive them to whether the account can reside in GovCloud or commercial. Now, with cloud comes a need for governance, and we started looking at the different AWS native services and what they could provide. We needed the ability to provide account users the means for provisioning approved resources while still limiting the access within their accounts. We also needed to be able to provide vetted internal design patterns for users to implement in their accounts. We needed to enforce a least privilege model, and in line with our Agile and DevOps transformation, we wanted to be able to manage this as infrastructure as code and DevOps principles. Can we use a code repository and pipeline to manage this across all of our AWS accounts? Lastly, and most important, this must support GovCloud, and AWS Service Catalog met all of that criteria. So this is our deployment of AWS Service Catalog. We utilize a hub and spoke model where we have a hub account consisting of all of our custom portfolios and products within each region. We have Service Catalog integrated with AWS organizations, and this allows us to easily share the portfolios and products to all of our spoke accounts. Within our portfolios, we primarily use template constraints and launch constraints. And template constraints allow us to restrict values for parameters within the spoke accounts. A use case for this would be maybe where you want to restrict test accounts to only a subset of instance types for an EC2 product. Launch constraints allow us to specify the principal used for the product within the spoke accounts. This is also known as principal to portfolio association. And it allows us to limit user access within their account while still giving them the ability to deploy resources through Service Catalog. We use SQS and Lambda within our hub account, and that's primarily used for granting principals in the spoke accounts access to our shared portfolios. For processing of new portfolios as well as newly provisioned accounts, Lambda functions will populate a message for the corresponding action in an SQS queue in each region of the hub account. Additional Lambda functions within each region will process the message from the queue and perform a cross-account assume role into the spoke accounts to implement the association of principals to the shared portfolio. Creation of our portfolio and products in our hub account is handled via GitLab. We have a GitLab repository where developers can commit CloudFormation templates in conjunction with a configuration file to specify various attributes such as portfolio association, product name, and so on. A CI/CD pipeline runs various SEA tooling, it performs validation, and then finally it does deployment of the portfolios and products to the Spoke account, or to the Hub account, sorry. And this consists of, again, various scripts to create the portfolios, create the products, create different product versions, and so on. Processing then again this within each region of our Hub account. All of this results in the end granting users of accounts the ability to provision Service Catalog products within their own accounts. So in summary, our deployment consisted of a few key characteristics. First, we have a governance process with code repository and CI/CD pipeline for product creation and management. We utilize the portfolio organization share as needed and then launch and template constraints. We develop code to support the association of the principal to the portfolio and all the secondary accounts. And for the initial deployment, we also engage with ProServe and the AWS Service Catalog team to develop an understanding of how best to utilize Service Catalog for our governance needs. They worked with us to develop and deploy the initial solution to support both GovCloud and commercial. All right, our first Service Catalog products were for EC2. We wanted to provide a golden AMI with all of our required agents, security policies, and configurations baked in. We also wanted to ensure that the resulting EC2 instances could be continuously patched and maintained. We needed to be able to easily provide updates to account users on new versions of the EC2, as well as be able to restrict deployment options as needed. Essentially, this is a vetted EC2 that is easily accessible to all users and is utilizing centralized standard code capable of supporting multiple versions of EC2. To support our EC2 products, we developed a few custom solutions to integrate with Service Catalog. We developed an AMI factory service used to build our golden AMIs as shown here in section 1. This service utilizes a combination of Systems Manager automation and Ansible to build the AMIs. AMIs are created with a baseline configuration and includes items such as required agents and security configurations. New versions of the AMIs are typically built monthly to include things such as OS patches or updated agents. And the golden AMIs are then finally shared to an AMI catalog service. The AMI catalog service, as noted in section 2, is responsible for registering the AMIs and sharing them out to all the accounts in our organization. It also registers custom SSM documents and distributor packages used for EC2 post-build management and shares those out as well to the secondary accounts. AMI catalog uses a variety of services to support this. Triggering of a golden AMI share to the AMI catalog initiates a Lambda function, which will then go ahead and post a message to an SQS queue in each region. It will initiate copying of the AMIs within each region. Another additional Lambda functions within each region will go ahead and process those SQS messages. It'll register the AMI in a registry table using DynamoDB, and then it'll go ahead and initiate the share of the AMIs to all of the accounts in our organization. We utilize the same framework to support registering and sharing of our SSM documents as well. So in section 3, our Service Catalog deployment is responsible for making the EC2 product available in secondary accounts. And this product is configured to utilize our golden AMI, and it also allows users to configure a maintenance window for post-management. Finally, in section 4, secondary accounts are pre-configured using a combination of Systems Manager automation and CloudFormation as part of the account build with all of the Systems Manager resources such as maintenance windows, patch baselines, and inventory. They can then use Service Catalog to provision the EC2, define their maintenance window, and have a resulting EC2 that is continuously patched and maintained using SSM for its lifecycle. So our Service Catalog products again started off with a single product for Red Hat EC2. We have since expanded our products. For EC2, we have created several different versions, both Windows and Linux, both with or without database installations on it. Beyond EC2 products, we also have several variations of RDS, such as Aurora, MariaDB, and MySQL. We've created products to assist with network configuration and accounts, such as security groups and also dedicated VPC creation. We develop products to support automation and integration as well within accounts. A few examples are a product to integrate CloudWatch alarms with Service Central for incidents. Another example is a product to clean up EBS snapshots using a defined threshold. And lastly, another example would be a product to configure required IAM roles for a monitoring tool that is looking to access CloudWatch metrics in the account. Not shown here, some of the other products we have been looking at as well to implement are products around cost optimization, like right-sizing of EC2 instances, as well as enablement of AWS services within accounts, where accounts are typically restricted to a set of internally approved AWS services at Lockheed. This shows a wide breadth of possibilities for Service Catalog. Now, we initially made the products just available in GovCloud to start. We recently enabled in commercial, able to use the exact same code and configurations in both GovCloud and commercial. And the bulk of our provisioned products continue to remain GovCloud with a 95% deployment. So we have several items planned on a roadmap for expanding our Service Catalog implementation. At Lockheed Martin, we utilize ServiceNow to support ITIL, or Information Technology Infrastructure Library Processes. This includes incident, problem, change, and configuration management, essentially IT service management. Near term, we are looking to implement the AWS Service Management Connector. Now, this connector allows for an integration of a subset of AWS services. The first is AWS Config. ServiceNow has a configuration management database, or CMDB, which is our record of authority for tracking configuration items, such as a server or a database, and the relationships throughout their lifecycle. We populate the CMDB with data from our on-premise environment as well as a subset of AWS accounts today. The connector will allow us to fill a gap with our AWS accounts using, again, resources and relationships from config. In addition to the CMDB, the connector also has the ability to support a service catalog. So ServiceNow has its own concept of a service catalog, and the connector will allow us to provision AWS Service Catalog products as a service catalog item in ServiceNow. A use case for this could be where maybe you want to limit AWS account access and require provisioning via your central catalog processes. Another use case would be utilizing the catalog item in other forms or workflows within ServiceNow. In addition to the AWS Service Catalog, it also supports initiating SSM automation documents within accounts. So beyond the AWS Service Management Connector, there are also several additional enhancements planned on our roadmap. We will be adding support for self-service actions. Self-service actions allow users to perform what we call day 2 operations on a provisioned product. These are operational tasks based off of SSM documents that are associated to a product within a portfolio. Now, these tasks could be doing things like initiating maintenance, it could be running health checks on various installed components, and so on. We will use a combination of native AWS SSM documents as well as custom SSM documents that we will deploy to accounts. We also have a need for implementing scheduled and automatic provisioned updates. There are 2 scenarios for this. One, we want to provide the ability for users to schedule automatic updates of provisioned products whenever a new version is available. They could define a corresponding maintenance window, and automation will handle the updating during the window. Second, we want to provide the ability for our cloud service teams to perform out-of-band updates. If there is a required security change or an urgent need to be able to update those products, we need the ability to be able to deploy those as needed. We are also looking to expand our product building blocks. We want to implement some of the basic resources as products to utilize in support of chain product or application deployment. We're also going to assess resources that we currently provision via our account provisioning process for migrating to Service Catalog products. This allows us to only embed resources in accounts that are truly required and create products for optional resources that can be provisioned by the user as needed. And lastly, as future shared AWS Service Catalog entities become available, we will continue to work to add support for them. So in closing, I wanted to share with you our lessons learned as we navigated through enabling governance in GovCloud. First, use AWS Service Catalog. It's an easy-to-use service for creating a central repository of IT services with minimal code development. The sharing capabilities make management of AWS Service Catalog via central account easy to set up with minimal effort. In addition, AWS Service Catalog is a service that strives to keep equal capabilities available in both GovCloud and commercial. We're able to utilize the same code for both, and we have the confidence that any new feature released by the service team will be available in both. Second, create a well-defined governance model around publishing of your products. Ensure your products are well architected and have security requirements embedded. Use automation, DevOps, infrastructure as code to support your portfolio and product management. Third, grow your catalog. Expanding products eases cloud adoption and helps to ensure your users are deploying compliant resources. Make sure you have the developers to support product creation or get commitment to either have a dedicated team or have commitment across your organization with engagement in product creation. Lastly, provide feedback to AWS. As you engage on your journey, let them know of ways to improve the service. Provide them your use cases for the service. If you encounter issues or functionality not working as expected, open cases to get them resolved. The more customer feedback, the better the service will be improved. Thank you, and I'll turn it back over to you, Kaushik.
Thank you, Diane. So, what's next? We would like you to be curious, which is why we are providing some resources for you to take a look at. We also need your feedback, not only on Service Catalog and how it works on AWS GovCloud regions, but also on the session that we are just about concluding. And now let's get some secure and compliant workloads into production for our AWS GovCloud US customers. Thank you.